Today we are moving into pyramids. So this is surface area of a pyramid. I really need to work at writing a little neater on here. I'm sorry. So a pyramid, okay? Can you tell me what is different about a pyramid and a prism? What makes something a pyramid versus a prism?
Well, I think a pyramid just has one base.
A pyramid only has one base, okay? And that base can be any polygon. So it can be a hexagonal pyramid, or it can be a square pyramid. I have a few of them. I think I have a triangular pyramid and a square pyramid. These guys are pyramids, right? Has a triangle on bottom, a square on bottom. It's a pyramid. It has a point on top. What are all of your lateral faces in a pyramid? Triangles, always. Okay, your lateral faces will always be triangles. Your base can be any polygon. All right? So that's the pyramids. And then you always name it by the shape of the base. We are going to focus on regular pyramids for majority of what we do. And a regular pyramid just has a regular polygon as its base. So like a regular hexagon would make a regular pyramid, or a regular quadrilateral, which would be a square, right? Noah, what are you doing that everyone's more interested in you right now? Right. Put your iPad away. Is it out? Is your iPad out? Okay, I'll just pay attention. Okay. In a regular pyramid, your triangles will all be isosceles, okay? So you'll always have isosceles triangles for your lateral faces in a regular pyramid. Let me draw you an example here. Okay, so let's say this is a regular what? What kind of pyramid? Pentagonal pyramid. Okay, this is a regular pentagonal pyramid. That means that all of our sides are equal length and all of our triangles are isosceles triangles. Okay, congruent isosceles triangles. In this pyramid, you will have a line here, okay? That is your height of the pyramid. But now in this figure, there's another height. We don't call it H, we call it L, like a cursive L, because we already have an H. But this height will always be perpendicular to the bottom, to the base of the figure. Your other height goes here. Okay, it cuts that isosceles triangle in half, and it will be perpendicular to the edge. So this right here, we call it L, and we call it our slant height. Okay, so you're going to have two different heights that come into play. The height is perpendicular to the base. This is just our height of the figure. Okay, so height of the pyramid. And then L is the slant height. Okay, if you would like, at some point on page 1618, there is a pyramid that you can manipulate. So you can move it around, you can look at the bottom, you can rotate it just to see it in more of a three-dimensional perspective if you would like to do that. It is there. Okay, what I'm going to show you is how we come up with the formulas for lateral area and surface area of this figure. So we're going to start with a net of a square pyramid. So you have a square base, and that means there's a triangle on every side here. Okay. So the length of each side of the square is going to be the same, so we're going to call those S for now. Those are not 5s, they're S's. Sorry, they always look too much similar to me. Then think about this line here. What is that? Is that H or L? the red line, that's the slant height, right? It's the height of the triangle, not the height of the pyramid. Okay, so this is our slant height. So if you think about it, this figure, our lateral area, is really 4 triangles. So how do you find the area of a triangle? 1/2 times base times height. So in this triangle, it's 1/2 times the length of a side, S, times the slant height, right? But there are 4 of those. So if you think about how we would do this, we can rearrange multiplication, right? That is the commutative property. You can move where things are, and it's still going to get you the same answer. So let's say we wrote it like this instead. 1/2 times 4 times S times L. Right? I can rearrange the order I multiply something in, and it's the same thing. Well, this 4S, what does that represent in this picture? What is it of the square? It's the perimeter of the square, right? So 4S is the perimeter of the base, which is what we've been calling P all this time. So your formula for lateral area is 1/2 times P times L. Okay, so rather than have to lay out a net and do all this work every time, you can just do 1/2 times the perimeter of the base times the slant height, and that will get you your lateral area. Okay? And then the surface area is very similar. It's the lateral area plus, yesterday it was 2B. What do you suppose it is today? B, right? Just one base. So LA plus B is going to be your surface area. So these are your 2 formulas that you're going to use. I will write them up on the board in a little bit. But just remember, L is your slant height, not your height of your figure anymore. Okay? Okay, so let's do a couple. First example. We're going to do a square pyramid. Where this is 8 centimeters, and this is 12 centimeters. All right, I want to find your lateral area and your surface area. So we're going to start with the lateral area. So first of all, the formula is 1/2 times P times L. I need to know what P is. Can anyone tell me? This is a square pyramid, by the way. What's P? Which is what number right now? 8 times 4, right? Your perimeter is going to be 8 plus 8 plus 8 plus 8, or 8 times 4. So it's 1/2 times 8 times 4, or 1/2 times 32. What's the slant height? What's L? That's the 12, right? So you get 1/2 times 32 times 12, and when you plug that in, you get 192 square centimeters. Okay, that's your lateral area. Then we want surface area. And our surface area is the lateral area plus 1B. So it's 192 plus what? What is B? What does B stand for? What of the base? Area of the base, okay? So the area of our base is what right now? 64. 8 times 8, right? So you're doing 192 plus 64. So you get a surface area of 256 square centimeters. Okay? Questions on that? Okay, that's as easy as they get. You didn't have to solve for anything really. You had to find the area, right? and find the perimeter. But the numbers are there for you. There's not a lot of
We have a problem where it's just lateral area.
where that's all they give you.
Yeah.
No. They'll always give you two things. Sometimes they'll give you the height and instead of the slant height, which we'll get to in just a minute. But okay, second one. Let's say you have a regular hexagonal pyramid. Fun to draw, right? They tell us that this right here, so our slant height is 9 inches, and this side here is 6 inches. Okay, it's a regular hexagonal pyramid, and we want lateral area and surface area, and we're going to round it to nearest inch because there's going to be some radicals in here. We're not going to go simplest radical right now. So let's think through what we got to do. Lateral area is 1/2 times the perimeter times the slant height. How am I going to find the perimeter of my base? It's a hexagon. That'd be the area of the base. Perimeter of the base. 6 times 6, right? It's a hexagon. Side lengths are 6, so 6 times 6, or 36 for your perimeter. Oops. And then what's L? 9. Okay, so again, not a lot that you have to do for that to find the lateral area. That comes out to 162. Okay, now we want surface area. And the surface area is your lateral area plus the area of the base. So you're going to take that 162 and you're going to add the area of the base. It is a regular hexagon. How do you find the area of a regular hexagon? Brett. That's the 1/2 AP you were talking about. So we already know the perimeter, right? The perimeter we said was 36. We found that earlier. We know the 1/2. We just need to figure out what is our apothem. So if we draw in the apothem here, that gives us a 30, 60, 90 triangle, which it looks backwards of what it should look right now, but that's just because of the perspective it's drawn at. What angle is the 30-degree angle? What angle is the 60? Which one's at the center of the hexagon? Is that the 30 or the 60 in a hexagon? That's the 30, right? 360 divided by 12 will get you there. So this is 30. So essentially you're looking at this triangle. Oops. All right, here's a 30. Here's the 60. This side is how long? 3, right? Cut it in half down here. So then your apothem is what? 3 rad 3. Okay, so that's our setup. We're going to plug that in to get, they said nearest what? Inch squared. So 1/2 times 3 rad 3. Don't forget to finish off your radical there, your parentheses, if your calculator starts them anyway. And you get 93.5 for your area of your base. And then you just add those together. So you get 256 if we round to the nearest square inch for our surface area. Okay? Questions on that?
How'd you get 92?
I plugged in 1/2 times 3 rad 3 times 36. The 1/2 AP. Okay, last one, and this is the one that takes a little bit of solving before you can really solve. So third example here. You have another square pyramid. Bless you. That's 9 inches. You have to pretend that height went down the center. I didn't draw a very good square for you. Sorry. This is 8 inches. And that's all they're going to give you right now. Okay? So if we're going to find the lateral area, it's going to be 1/2 PL. What is P? The area of the base, which is going to be 9 times 4, right? Your area is going to be base times height, or 9 times, your area of your base. Your perimeter of your base is going to be 9 times 4. There are 4 of those 9s all the way around. So 1/2 times 36, 9 times 4. What's L? We don't know, okay? Anyone see a way that you could find it? Pythagorean Theorem. You have a triangle with the slant height right here. Okay, now I didn't draw it very well, so it doesn't look like it got cut in half, but this 9 here gets cut in half when you take the height and go to the side. So this is 4.5, this is 8, this is our slant height. So you're going to go 4.5 squared plus 8 squared equals the slant height squared. Okay, so if we solve that Pythagorean theorem, 4.5 squared plus 8 squared, take the square root of that, you get 9. Okay, here's the deal. Our end result is going to round to the nearest 10th. So if they ask you to round to the nearest 10th, but it's not your final answer yet, give it at least 2, I would say maybe 3 decimal places. So round to the nearest 1,000th, I would say. So this comes out to a slant height of 9.179. That way when you round to the nearest 10th, it really is a true rounding to the nearest 10th at the end. Okay? So that's our slant height. So we're going to plug that in here, 9.179, and then plug that in. Your lateral area comes out to 165.2 square inches. Okay, then your last thing to find the surface area, now this one's quick. You do your lateral area plus the area of the base. So your lateral area is 165.2. We already found that. What's the area of your base? 81. 9 times 9. Base times height. 9 times 9 here. So add that together. You get a surface area of 246.2 square inches. Okay, so if they give you a height, you probably have to do the Pythagorean theorem because they probably didn't give you the slant height if they're giving you the height. Okay, so look for Pythagorean theorem a lot in this. The only variable that changed was now we have L, which is slant height. Okay, questions on that? Yeah, Kenny.